Space has many mysteries, but how can Mercury, the closest planet to the Sun, have ice? This planet experiences some of the most extreme temperature variations in our solar system. With daytime temperatures soaring above 800 degrees Fahrenheit and no substantial atmosphere to distribute heat, Mercury seems like the last place you'd expect to find ice. Yet, against all intuitive expectations, scientists have confirmed the presence of water ice in Mercury's permanently shadowed craters. This fascinating paradox reveals much about the nature of our solar system and the surprising ways water can persist even in seemingly hostile environments. Despite Mercury's proximity to the Sun, its unique orbital characteristics create conditions that allow ice to exist on its surface. Mercury has almost no axial tilt, meaning the Sun's rays always strike the planet's equator at roughly the same angle. This creates permanent shadows at the poles that impact craters near Mercury's poles with deep floors which never receive direct sunlight. Without sunlight or a substantial atmosphere to trap and distribute heat, temperatures in these permanently shadowed regions plummet to approximately -280 degrees Fahrenheit, well below the freezing point of water. These permanently shadowed craters essentially function as cold traps, where any volatile materials like water ice can remain stable for billions of years, despite being on the closest planet to the Sun. The journey to confirming ice on Mercury spans several decades and multiple scientific missions. The Arecibo radio telescope detected unusual radar-bright patches at Mercury's poles. These highly reflective areas corresponded to the locations of large impact craters mapped by NASA's Mariner 10 spacecraft. However, since Mariner 10 had only mapped less than 50% of the planet, scientists couldn't make a definitive conclusion. Do us a quick favor and like if you're enjoying this episode. The breakthrough came with NASA's MESSENGER, Mercury Surface, Space Environment, Geochemistry, and Ranging mission, when it provided conclusive evidence through multiple lines of investigation. High-resolution images confirmed that all radar-bright features at Mercury's north and south poles lie within permanently shadowed regions. MESSENGER's Mercury Dual Imaging System measured temperatures in these shadowed craters, confirming they were cold enough to preserve ice for billions of years. The spacecraft also observed highly reflective deposits characteristic of exposed ice in the coldest craters. The water ice in Mercury's polar regions, if spread over an area the size of Washington, D.C., would be more than 2 miles thick. These deposits are primarily concentrated in large craters like Prokofiev and Fuller at the North Pole. In the coldest craters, water ice is exposed directly at the surface, appearing as bright reflective deposits. In slightly warmer polar craters, the ice is buried beneath an unusual dark material, a layer of organic-rich compounds approximately 4 inches thick. This dark layer acts as an insulating blanket, protecting the underlying ice from sublimation. The dark material covering much of Mercury's ice is likely a mix of complex organic compounds delivered by the impacts of comets and volatile-rich asteroids, the same objects that likely delivered water to the innermost planet. This material appears darker than anything else on Mercury's surface and has sharp boundaries, suggesting it's relatively young in geological terms. The discovery of ice on Mercury has profound implications for our understanding of the solar system. It demonstrates that water is more widespread throughout the solar system than previously thought, even in seemingly inhospitable environments. The presence of these volatile materials provides clues about the formation and evolution of the inner solar system. While human exploration of Mercury remains a distant prospect, these ice deposits could theoretically serve as a valuable resource for future missions, providing water, oxygen, and hydrogen. The mechanisms that preserve ice on Mercury likely operate on other airless bodies like the Moon, where NASA has also confirmed the presence of water ice in permanently shadowed craters. These frozen deposits, preserved in eternal darkness while the surrounding landscape bakes in solar radiation, remind us that our solar system still holds many surprises waiting to be discovered. Sometimes the most significant discoveries are found precisely where we least expect them. Leave a comment with your thoughts if you've made it this far.